So we are doing partition equal sum problem, subset problem, partition equal subset sum. So this is a medium level leet code question. In this question, we are having given an integer array. We have to return true if we can partition this array into two subsets such that sum of both subsets is equal to it's same, right? So in this case, we have one subset as 155, which is sum to 11, and second is 11. They are having same sum, so we are returning true. In next example, we cannot find any such subsets which are having equal sum. So now let us solve the question. So we will be given an array. The integer array. So let us go by example. That was 1, 11, 5 and 5. And we have created one part as 11, second one is 1, then 5 and 5, right? Now we can say that sum of both these is equal to total sum. So but also that sum of the individual partitions is equal. So let us assume each sum of each partition is p, then p plus p equal to total sum s. So 2p equal to s. So this implies that s should be even. Now, if our example is such that our s is odd, then we can simply return false, as there does not exist any partition which has which can be if suppose sum was 23, then there was no way that we could divide it in some form like 11.5 as 11.5 as the values that we are given are integer type, so we cannot do that. So it has to be either suppose 10, 13, 11, 12, but cannot be equal, right? So we have first found out a thing that if sum uh, sum modulo 2 equal to 1, then false. That is it. So now if we have sum as even, then we have to further uh, think of what we can do. So now we have sum as even. Now we have to find two subsets which are having sum as p. Two subsets. But as we know that if suppose our array is this vector array, whatever you can call, we have found some subset with p as its sum, then the remaining subset will also be having sum as p, as p is in sum by 2, right? P is sum by 2. I'm sorry. So yeah, so we can simply say that if we can find one subset with sum equal to total sum by 2, then the remaining will be having sum as uh, total sum by 2 itself. So our target is now find one subset such that its sum is total by 2. So uh, here we have, so using our example, we can say that we have 1, then 11, then 5 and 5. Now So also we have target sum as 11, right? As total sum is 22, then target sum t equal to 11, right? Now let us traverse our array. So if we are at this position, then we have target sum 11 and current value of current element is 5. Then we have two choices, either to include our 5 in our partition or not include. So this looks like a recursive structure. So let me make a recursive tree for this. So this is our array 1, 11, 5, 5. Now also with this we have target 11. Now we can either uh, take 5 or we can just ignore it. We have two conditions. If we ignore the 5, then our target for remaining will be 5, 11 only. But for this case, it will be 11 minus 5, which will be 6. Now, for remaining elements, now uh, here we are again have a choice to take next 5 or not. As our target is greater than 5, then we can easily accommodate it. So we will take it. Now our target will be 1 and we are ignoring here. Correct? Target is 6 only. Next element, no, 11. Can we take 11? Because our target is 1 only. We cannot, because it will exceed our limit, and we don't want that. We want anything which is equal to 11. So we cannot. We will here we have only one choice, to simply ignore 11. So only 5, 5 and 1. Now the last case. Here we have target or equal to 1 and remaining element is also target equal to 1 and remaining element also equal to 1, right? So in this case, what we can do, we can again either take, or we can simply return true from here only, as we don't have to find count, and so simply return true, as our target is equal to current element. So this will match it, and we will simply return true from here, then again true from here. Now we are at, but as we know that in OR condition, if we get our first value as true, then we don't even bother to go to the second area, right? So we will again return true from here and true to the function. That is it. So looks simple but messy also at the same time. So how we can solve this question? So our suppose function is f of, our arguments were array. Let us name it as nums as per given in question. N is size and S is our yeah, S. I have used S in the code, so let us go with S. Here S is target, right? S is target. So now what we did is, also N is size. So it so that means that we have n elements, and nth element will be at n minus 1. place, right? So at every time we are checking for some ith or nth element, we will be going to its n minus 1 element in nums. That should be keep in mind. So now what this function says, if our nums, let me write down here, if nums of n minus 1 is greater than s. Now what does that mean? If our current element is greater than what is our target. So the way, like, as we have discussed here, if so here current element was 11 in this call and target was 1. So current element was greater and we could not take it. So simply we will ignore the element and call function of nums then for next element, and sum will be as it is, correct? But if nums is less than equal to sum, that means our sum is nums of n minus 1. That means the sum is greater enough to take our element, current element. So in that case, what we can do is what we have done. Let us just go here. So if we here uh, mm, so here our uh, s was 6, also num was 5. So we had two choices. We made two choices, either to take 5 or not take, correct? And we have written what is, like, if it is possible from here or from here, right? If we could find one of the case in any one call, we are good, correct? So in this case, we can simply say that f of nums n minus 1 s or f of nums n minus 1 s minus nums of n minus 1. Now, are you getting? We have reduced this part, and now in next function call, it will be called on some different target sum, as we have utilized nums of I in our partition. So remaining values has to be covered from remaining elements. And what is the remaining value? S minus nums of I minus 1. So that is basic logic. Also now let us check what might be the base cases. So here base cases are, so if our sum is 0, then we will simply return true, as we have got our partition. If not, and if our n is now 0, so here n denotes number of elements, not the index, right? So if n is 0, then we cannot accommodate uh, any number. So in this case, we will simply return false, as we have no space, or suppose in this case there would be some target sum, but as we have no element to acquire to provide for that, we will simply return false. Thank you.